So we've got all this data together now. So we have our image layer at the bottom, which has got our global imagery sitting on top of our global DEM to get some hill shading. Then on top of that, I've got the hand data, the height above nearest drainage. Then on top of that, we've got our opacity modulated upstream drainage area data, and then on top of that, I've got the channel width data. So we'll take a closer look at this data. So I'm just going to close this preview window and then open an external window. Move that out of the way over there. Put that one there. I guess that's about right, or we can make it a tiny bit bigger. I'll just turn off a couple of layers and then we'll zoom in here. Actually, sorry, I'll bring that one on and that one off. Zoom in here. So here's the Sydney Basin. The Hawkesbury Nepean River system is this river here. It flows up around here and then flows up here. This is the Nepean, and comes all the way along here and goes blah. And this is Sydney, the Sydney Basin here, and here's the harbour. So this system is flooding at the moment, and it's flooded twice this year already. So if we have our tooltip on, so if we go and look here at the end of the Hawkesbury, you can see the value there on screen, 21,690 square kilometres of upstream drainage area. So that's how many square kilometres is being captured. So it's pretty large, I suppose, and with lots of rainfall, there'll be lots of water coming down. Let's just turn on the width data. So this is the width of the channel. So, and this is the problem area here. So out here, the channel goes up to 450 meters wide. It's quite wide, 500 meters wide. But in here, you can see there's these choke points, and in particular, this is the Sackville Gorge here. And in this area, the river's only 130 meters wide, 110 meters wide, 170 meters wide. So this is a significant choke point, and this is one of the reasons that the system floods, I suppose, because the water gets backed up here and then can't escape from these areas here. So we'll just bring on this other layer, the height above drainage channel layer. So you can see the area that's affected. So, where we have this colour, that's our low heights, less than 20 meters above the nearest drainage channel. Now let me just check that. The colour. So I'm using a brown-blue colour scale. So the brown is the lowest. So these areas in here in particular are very low and prone to flooding along the Hawkesbury River, which comes along here. So let's come back out. And there's a little town up here, so let's go back to, let's take that one off, and we have our rivers back on. Come up here to a little town called Lismore, which has had a miserable time this year and has been flooded twice. So you can see this river system here. It's like a big cup, and all these rivers in here all flow into this one point. and unfortunately that's right where the town sits. So we look at the area. We're getting 1,387 square kilometres, so a fair amount of catchment there, and it's all being brought into this one point at the town of Lismore. The town sort of sits in here in these low-lying areas. So if we turn on our hand data again, you can see, so just zooming out, this is the Northern Rivers region. These areas here are all the very low-lying areas and subject to flooding. And coming back into Lismore, Lismore sits in one of these areas. You can see this tongue of low-lying land that comes up in here, and all of this area, I suppose, is prone to flooding. This is less than 20 metres. You can see the values there, only a few metres, up to 20 there as it goes up the hills, but most of it quite low-lying. And I suppose the other reason that that Lismore floods is that once the water gets here, it's virtually at sea level, and it's got to flow all the way out here and around through all this very low-lying land to get out to here. So let's see if we can, maybe we can see that. We'll turn this off and just turn that imagery off for a second. So now we're just getting the value of the terrain. So the terrain in here, you're looking at only about 10 meters above sea level, and it's got to get out here at sea level. So there's very little drop off in height from this point in the river system down to the exit at the sea. And of course, if there's a high tide or a storm surge, as there has been recently, then this is going to be even more choked, and water's going to find it even harder to drain out of these areas. So that's my look at the Merit Hydro dataset, Global Hydrography or Hydrology datasets. There's a reminder of the webpage there. From downloading through to converting into MRR, and then visualizing and analyzing with ProRaster. Thanks for watching. See you next time.